Welcome back to Grade 12 Mathematics. Today we're gonna focus on Unit 7, Calculus. So under Calculus, we're gonna do gradients, derivatives, tangents, and cubic graphs. So we're gonna look at differentiation. This is like a symbol for differentiation. Let's say you've got f of x is equals to 2x plus 1. So if you are then the symbol for differentiation is this, right? Or you can write it as dy dx. So remember your y is also equals to f of x. So it means you're differentiating 2x plus 1 dx. You're differentiating x. Then we look at this. This is more like from the equation y is equals to mx plus c, which is the equation of a straight line. Straight line equation, right? So the m represents the gradient. So remember, gradient is change in y over change in x. So for example, you've got a graph like this. Let's just this is y-axis, x-axis, and then we say y is equals to x. So this is the line. So it means change in 2 points. So let's say I've got 2 points. Let me use a different color so that you can see. I've got point 1 here and point 2. So this one we can label it x1, and the corresponding one is y1. So in other words, this coordinate is x1, y1. Then the other one will be more like x2, and this one y2. So the coordinate will be x2, y2. So the gradient, use 2 points, change in x over change in y. So it will be y2 minus y1 over x2 minus x1. So that will be the gradient m. So that's how we get to this formula, right? Are we together? Then in order to find stationary points, so the stationary point, for example, you can have a graph like this. So the stationary point can be a point at the bottom of the graph like this one. So in order to find that stationary point, you say you find the gradient of. So it means you differentiate the equation, then you equate it to 0. So for example, if you have an equation like x cubed plus x squared. Maybe let me just delete this a bit so that I can create more. So I've got an equation f of x is equal to x cubed plus x maybe 2x squared plus 10x, right? So if you are to find the stationary point, then it means you first differentiate. Then differentiate. So it means you are saying plus 2x squared right dx. Then that answer you equate it to 0. So because I'm not gonna be doing differentiation now at the beginning of the chapter, because we're gonna learn how to do it later. But generally, if you differentiate, the answer is supposed to be 3 squared plus 4x plus 10 is equals to 0. Then you solve for x. So for s, you do a quadratic equation. Then when you find x, then you find the stationary points. So when you solve this equation, you find something like x plus a. Let's say x is equals to a or b. Then those values, you put them back into this one to get the y value. But we're not gonna do it now because it's gonna complicate things, because we want to first learn how to do the calculus. So we start it slowly, then we ease in into the chapter. So don't worry about it for now. So generally, we're gonna look at gradients, derivatives, tangents, and cubic graphs. So let's move on. So for this unit roadmap, so generally the unit moves from average change to exact change, then applies derivatives to graphs. So first part, you do the average gradient, which is the slope between 2 points on a curve. Then you're gonna do the instantaneous gradient, which is the gradient at a specific point. So average, it uses 2 points. Average gradient uses 2 points, which means you have two coordinates, like what we did on the straight line. There's a 1 point and the second point 1 and point 2. Then use 2 points. But on a derivative, we are using instantaneous, which means you are using 1 point. Then you find the slope at that point, which is more like a tangent to that point. So then we also use the derivative of and then find the coordinate so these are the coordinate of that instantaneous point, and these are the derivative of the equation. So we also gonna look into stationary points. So by first getting the derivative of f of x, then we equate it to 0 derivative, then we get the stationary points. Then we're also going to look at cubic sketching, so use intercepts, turning points, and inflection. So the study logic, so a derivative is not just a rule for changing exponent, it represents the gradient of the curve at an exact point. Then most questions, when you look at the exam logic, most questions ask learners to differentiate, substitute correctly, and interpret the results in a graph or a rate of change language. So that's basically what this chapter is gonna focus on. So we're gonna take it step by step, so don't worry too much about it. So let's move on. So let's start with the simple logic. So when we talk about average gradient, it means average gradient is the slope of a second between 2 points. So if you look at the graph below, you see the line in red is the second line. So it means you're drawing 2 points, this one and this one, then you join them, right? So that is the second line. So it means is the average, let me use a different color here, is the average of this line, the average gradient between this. So remember, this blue line is curving like this, more like this. So what we are doing, the second line, it just creates a gradient which gives you the average gradient between those 2 points. So that's what the second means. So that gradient, we measure it by m, which is change in y over change in x, which is the 2 coordinates. So we've already done it. So in other words, if you are saying at point A on the x-axis, there is a and fa on the y-axis. So in other words, if you are given an equation like f of x is equals to 3 cubed plus 10 squared. Let's say this is your equation. So it means that f at FA, it's just substituting A into that equation, right? Because we are saying at x equals to A, which is more like